We want to solve the simultaneous equations 5x minus 6y is equal to 13. Call this equation 1. And 3x minus 8y is equal to minus 1, which we'll call equation 2. Note how we have different numbers of x's and of y's. We could get the same number of y's by doing 1 times 8. This would give us 40x. Take away 48y is equal to 8 times 13, which is 104. If we then did 2 multiplied by 6, we'd get 18x. Take away 48y is equal to minus 6. Note how we now have the same number of y's. However, we could produce the same result by multiplying 1 by 4. We then get 20x, take away 24y is equal to 52. And multiplying equation 2 by 3 gives 9x, take away 24y is equal to minus 3. Note how we have the same number of y's here, but overall the numbers are smaller. We're going to work with the pair of equations that had the smaller numbers. Smaller numbers mean our calculations are easier. However, don't worry if you don't necessarily spot the best multipliers for the two equations. It will still work even if you use the larger numbers. Call this one 3 and this one 4. We have the same number of y's and the signs are the same, which means we're going to subtract. Do 3 take away 4. Doing it this way because we have more x's in number 3. 20 take away 9 is 11, so we have 11 x's. We then do 52 minus 3, which will become 55. Therefore x is equal to 5. When we substitute back in, always go back to an original equation. I'm going to sub in number 1. If x is 5, this is 25. Take away 6y is equal to 13. Take away 25 from both sides, and we get minus 6y is equal to minus 12. It follows that y is equal to 2. And so our solution is x is 5 and y is 2. As always, we should check solutions. Looking at number 1, 5 5s are 25, 6 2s are 12, 25 take 12 is 13, and this checks out. For number 2, 3 5s are 15, take away 8 2s, which is 16, 15 take 16 is minus 1, and this checks out as well. We now have 2x minus 5y is equal to 31. Call this equation 1. And 4x take away 2y is equal to 38. Call this number 2. Different x's and different y's. If we did equation 1 times 2, we'd have 4x take 10y is equal to 62. If we then did equation 2 multiplied by 5, we'd get 20x take away 10y is equal to 5 times 38, which is 190. Call this equation 4. We now have the same number of y's. An alternative is to multiply equation 1 by 2, as we did before, giving us 4x minus 10y is equal to 62. Then equation 2 is 4x take away 2y is equal to 38. Note how we have the same number of x's. Call this 3, and this one was 2. So we have an alternative. Doing this produces us a pair of equations with the same number of x's. Doing this provides us with a pair of equations with the same number of y's. So let's look at this one. The same number of y's with the same sign means that we subtract. Do equation 4, take away equation 3. 20x take 4x gives 16x. The y's disappear, and 190 take 62 is 128, giving us that x is equal to 8. If we were going to go ahead and solve this, we would then take this value of 8 and substitute back into one of the original 2 equations in order to find the value of y. Let's look at using the other pair of equations. We have the same number of x's and the sign is the same, so once again we subtract. Do equation 2, take away equation 3. The x's disappear. Here we have minus 2y, take away minus 10y. This is minus 2y plus 10y, which is 8y. We then have 38 take 62, which is minus 24, giving us that y is minus 3. If we were going ahead to solve the simultaneous equations, we would take this value and substitute back into one of the original equations to find the value of x. So we have a choice of methods. What I would say is that often pupils get this bit wrong. Getting the same number of x's often leads to a situation where you have a minus minus. And often people forget that minus minus makes a plus. So even though it took more work to get these equations with the same number of y's, I often think that it's the best way to do it.